you live in a cold, dark universe. At least that's what scientists think for now. You've probably heard some news that the whole expanding universe thing, the standard model, is going bonkers. There's all these new toys, these satellites. They're finding out this stuff that's just going to blow our minds. I've been actually looking at this stuff, and I've been down the rabbit hole with holographic universes, multiverses, bubbleverses, even the conscious universe, right? Our official theory of the way the universe works right now is called the Lambda CDM model. That's the Greek letter L, and then CDM means cold, dark matter. I have a friend who's an astrophysicist, Brian, who's a genius astrophysicist. So I thought I had him. There's all these lambdas, and what do they each mean, and what's the lambda? I'm going to ask him about what the cosmological constant is. What is the cosmological constant?
Okay. Well, let's see. That's a term that Einstein put onto his cosmological equation, and later, after better telescopes were developed, took it off of the equation.
Okay.
It's kind of a long story. Do you want to tell what you know about it, Rob?
No.
You tell me.
Okay. Well, it all started when Einstein decided to apply his theory of general relativity to the universe. And when he did this, he noticed the universe had to be either expanding or contracting. So he talked to as many astronomers and cosmologists as he could to ask what they were observing, to see if it matched what he had found in his theory. He asked them, are the stars moving apart from each other, suggesting an expanding universe? Or are they coming in towards each other, which would indicate a contracting universe? When they looked into their telescopes, all of the astronomers observed the same thing.
Okay.
They saw a universe that was static, where all the stars stayed in one place and didn't move. So this puzzled Einstein. So he fretted over this, and he really didn't want to do this, Rob. He was highly reluctant.
Oh.
But he added on what he called the cosmological constant.
I see. It was political.
But if he called it the cosmological constant, that seems like he's almost making fun of them, you know?
That's a good one, Rob. I can see Einstein joking them like, hey, they want a constant universe? I'll give them a static universe. I can make my equation however they want it.
If you draw dots on...
I also could see him naming it the cosmological constant so that they would never name it the Einstein constant.
Yeah. So basically, they added, but they didn't mean that it was a constant. They just kind of described it as the name for the theory of a universe, right?
Well, actually, he did make it a constant. It's the constant energy density in the vacuum of space.
Was it in ratio?
Yes, energy density is a ratio, Rob. It's the energy per volume.
What did Einstein measure his lambda constant in?
So energy density would be energy over volume. That comes out to joules per meter cubed.
What is it exactly describing?
Energy per volume, that breaks down to force over area, which is a pressure. We add pressure to our tires in PSI, or pounds per square inch. And when we put pressure into our tire, it pushes on the walls of the tire. So this pressure pushed on the universe with the same force that gravity was pulling inward, giving you an equilibrium. Thereby you have a static universe. And that's what it's describing.
Ta-da.
Now, you got to recognize, at the time, the telescopes weren't very powerful. We could see within our own Milky Way galaxy, and yeah, but it wasn't very long after that they were building better and better telescopes. And by 1929, this allowed Mr. Hubble to verify that there were not only other galaxies out there, but the universe was expanding after all. And Einstein thought, well, now I can throw the cosmological constant out of my equation because I was correct in the first place. But he couldn't get rid of it forever. So there's a little bit of a plot twist to this story, Rob.
Oh, God.
In 1998, they observed that the universe is not only expanding, but it's expanding at an accelerating rate.
So they had other theories.
Yes, they did. And this new theory included revising the cosmological constant. And we all know now they call this new theory the Standard Model. You know, the Standard Model is a evolution of Einstein's theory.
The Lambda CDM model is the most accepted theory in cosmology today.
Rob, you're right there. The Standard Model is so popular because it's a very simple theory, and it explains so many things we observe. It explains the accelerating expansion of the universe. It explains the flatness of the universe. And it matches observations like the cosmic microwave background.
Well,
The abundance of light elements like hydrogen and helium, lithium, the large-scale structure of the universe. It explains how clusters of galaxies form, or the voids, or where you don't see many galaxies at all. Well, this is the genius of Einstein. He must have thought to himself, how can I describe something that provides a counter push to gravity's pull? And he came up with the concept of the energy density of the vacuum of space. But now we know that we can't detect this energy. So now the Standard Model Lambda CDM calls lambda the energy density of dark energy. In the late 90s, we got evidence that the expansion of the universe was accelerating. So they took lambda out of the attic, dusted it off, and revived lambda. And so now lambda is the energy density of dark energy. It's the exact same concept that Einstein invented. And this provides the pressure that pushes on and overcomes the pull of gravity, thereby causing the universe to expand at an accelerating rate.
So why are there so many lambda theories out there, Brian?
Well, there's so many different ways to measure lambda. One group might use supernova, which are like studying the markers of distance in the universe. Some will use the cosmic microwave background to get a snapshot of the early universe. Another group might look at the large-scale structure of the universe to look at the evidence for how the universe expanded. And all these methods come with different errors, different assumptions, or different challenges.
Everybody uses lambda on purpose, like automatically?
Well, if you're going to study cosmology, the standard model is like the foundation. So you study that first to get the lingo, the bedrock of what you're going to be studying.
So when the explosion of lambda theories came around, did they all use lambda in the sense of a constant?
But yes, in the standard model, lambda is always a constant.
One of the reasons I had Brian on my show is because I'll ask him questions about cosmology, and I'll get such a thorough answer, an answer that is sometimes above my head, sometimes not. But now we can all listen together and get it straight live on audio.
So I'm going to go to a commercial. Thanks for giving me those opinions, and I'm going to have another round with you when we come back.
Thanks.
Up next, Professor Diederich and the Dark Wave podcast will discuss the standard model of cosmology.